So now let's consider an example, and I will show you how to perform information reduction. So let's go back to the LED problems. If we are trying to identify what number it will indicate by human beings, we have to use all the 7 segments. If we have one of the segments missing, then we may not be able to tell exactly what it is by human beings. If you are trying to solve this kind of problem by computers or by pattern recognition, then you may find that some of the 7 segments may be redundant. It may not be necessary to have some of the segments. So in this case, we will have 7 conditions and 1 conclusion. And we have to tell which of the segments are not necessary in the recognition of digits, not by human beings, by machines. By human beings, we need all 7 segments. So for this example, we have to create a truth table where for each value here, we will have the indicator of the 7 segments. For instance, if we have 0, we will have all the 6 elements by 0, and with the middle one denoted by 0, or the other ones are 1. So we have we will have all this on, but this one is 0, and this one happens to be the G definition here, and it indicated this is a 0. And then for 5, we may also establish a truth table like this. And now we can create a matrix. By this part, we can create a C matrix. And by this column, we can have a D matrix. And then we can have an X matrix, which is composed of C and D. We can establish an X matrix first. And we can easily establish a C matrix and a D matrix, and from which we can easily establish an X matrix. And in the X matrix, the index of 1 to 7 are conditions, and the 8th one are the conclusion or decision. The 8th column of X are conclusion. So we can call a function called, we can use another function in fact, redu for reduce, where we can specify the whole X matrix here, and we can specify the condition index 1 to 7 here, and this one is 8. So now if we run this command, we will see that 1, 2, 5, 6, 7, we have 3 and 4 missing, which means that the 3rd and the 4th segment may not be necessary. So let's go back to see what the 3rd and 4th are. So see, this is the 3rd and this is the 4th segment. So these 2 are redundant. We can remove them, and we can display all the 10 digits in this way. It is hard for us actually. However, if we are trying to use computer to recognize from them which is which, it is much easier because there is only 5 segments to identify. However, in traditional way we have all 6 segments. So in this case we can delete, we can remove 2 of the segments. So this is one of the example of of information reduction. Now let's consider another problem, which is a subproblem diagnosis. It's quite similar to Swan blue problem. We have created a table like this, where we have different medical conditions. One is acting cough, the other one is great difficulty, blood test, another is temperature level higher than 36 degrees centigrade. We have all the column indicated by one condition. And this is the conclusion. If it is 1, then it should be diagnosed. And if it is 0, then it should be excluded. So in this table we have this part as matrix C, and this column as matrix D, and we can compose C and D together. There might be some problem in the data, I think. So, C command might be problems. Okay. Size. So there is a problem in running the code, actually. So if you can specify C and D, and then you can get an X matrix. And in the X matrix, there should be 13 columns. The first 12 columns are conditions. The last one, the 13th one, is the decision. So we can use a command like this to find which other conditions are redundant. So these are the indices from 1 to 12, and this is the conclusion. This is the decision, and this is the whole matrix. And we may find that the result is Y is 3 and 4, from which it means that the third and fourth conditions are necessary, should not be reduced, and the other conditions should be reduced. So now I've finished my presentation for the whole lecture. Okay, thanks. Any questions? I feel I do not have enough time to explain too much about it, but maybe sometime later you might this kind of problem maybe before, as you have learned this one before, and so you think you can start out with it. Okay.